There, everybody in YouTube land. I dug this out of one of my boxes. I totally forgot that I built this thing. So I decided to do a quick video on it. Basically, this board here is a digital audio spectrum analyzer board. And this board was actually designed to go into a car or automobile, because it has your 3 connections here for 12 volts ground, and then your remote dual voltage regulators, dual processors for the LED arrays, and then the actual FFT processor and analog circuitry in the corner. And what this was actually designed to do is go in the back of a car window that has LED strips on, for a show car. And the LED strips were your typical off-the-shelf WS2812 addressable. Nothing special there. But unfortunately, that project never fully happened. And this was actually designed to be a remote knob that goes into the dashboard while that goes in the trunk. That way you can adjust the levels. So, that project never got completed because I ended up changing jobs, and, well, here it sits. And it got thrown into a box totally forgotten about until the other day. So what I actually did was write a little bit of firmware code to drive this guy right here. This was a Mackie mixing console meter bridge. I think, if I'm not mistaken, it was like a 16 or a 24 channel. And there's the actual stamp there from copyright 1997, Mackie Designs, board being made in 98. This board is nothing more than one really big shift register. 74HC595 series chips drive the LED arrays. And that's a lot of LEDs. This thing pulls a lot of current. You got to think 20 to 30 milliamps per LED times 12. I think there's 12 LEDs here times all those LEDs. That's a lot of current. And the load is shared between the two 5-volt regulators, and they still get hot. And notice when I designed this board was designed to have via stitching to try to pull some of the heat away. And it helps a bit. The analog circuit is using, right here is a dual rail. So basically a rail splitter. It takes the 5 volts and splits it to positive, negative 2.5 volts and creates a false ground. And that's why if you see the upper planes, copper planes, they're split because of the dual rail system. Standard RCA inputs. Anyway, without further ado, I'm going to go ahead and hit some music here for a second. And I can't play it too much because of the copyright police. You know how that goes. Alright, that's it. Can't play anymore. So, there you have it. That right there is a poor man's audio spectrum analyzer. So, now, this is the precursor of a couple more that I want to make down the road. But, instead of ordering a bunch of LED strips, I just kind of put this thing to use. And, I can unclip this and remove it and get half if I only wanted half. But, what's the fun in that? Now, the next question is, what to do with this thing. Anyways, thank you for watching. If you have a comment, please feel free to leave one.